Alright, so for each of these questions, we're going to draw a bell curve, and that's just drawing a rough sketch is fine. Okay, and our mean is 44. So I draw that line right down the middle, and what we have to understand is our mean splits the bell curve in half. If our mean is 44, half of our scores are going to be bigger than 44, half the scores are going to be less than 44. Our standard deviation is 7, so we're going to add 7 3 times. That puts me at 51, 58, and 65. And on this side, we're going to subtract 7, 37, 30, and 23. Okay? And now, our percentages are always this. 34%, 34%, within one standard deviation of the mean. As we go out 2 standard deviations, it's another 13.5%, 13.5%. When we go 3 away, or 3 standard deviations away from the mean, now you're talking about 2.35 and 2.35. And finally, those extremes outside of 23 and 65 are 0.5 and 0.15 and 0.15. So that's what our normal distribution curve would be. All right. So on the test, this is the first thing you're going to draw out, is that curve with the numbers here. So to answer the questions off the curve, and I would draw the curve first, you will get points for the curve. We're just following along the curve. Now, keep in mind, on a question like this, there's a limit to what numbers I can ask about. Okay? Like, I can't ask you right now without a calculator what the range is between 38 and 42. But I can ask numbers on this graph. 37 and 41. What is the percent chance your score is between 37 and 51? 34 and 34 is 68%. You're just adding the percentages. That's it. What is the percent chance your score is greater than 58? Here's 58, 2.35, and 0.15. There's a 2.5% chance you have a score greater than 58. What is the percent chance your score is not between 30 and 44? 30 and 44 is 34 and 13.5. That's 37.5. That's 47.5. So if I want to know where I'm not between 30 and 44, it's simply 100% minus 47.5%, and that gives me 52.5%. There's a 52.5% chance I'm not going to be in that range. All right, so we start with our bell curve here. 77 is in the middle, and we're adding 6 3 times, so 83, 89, and 95. Coming this way, 71, 65, and 59. And now all of a sudden my numbers with the questions are not as exact. So now we need to use our calculator. Okay, even though 83 is exact, 70 is not. So in our calculator, if I want to find the percent chance of the score being between 70 and 83, I'm going to turn my calculator on. I'm going to hit second function vars, which gets me to distribution. Now, when you're doing it between 2 numbers, after you do second function vars, you hit the 2 button, and you should get a screen with lower, upper, and then that little U that means mean, and that little circle that's going to mean standard deviation. Okay? My lower number here is 70. I put that in as my lower. My upper is 83. I put it in as my upper. My average is 76, and my standard deviation is 6, and then I hit enter 3 times. And I get 71.9 or 72% about. Now, this should make sense in this sense. Between 71 and 83, now I did 70 and 83, 71 and 83, that's 68%. So for me to add one more number on it, makes sense that it'd be just a few more percentage points. All right, you're not going to get the exact number in your head, but you should be able to look at the numbers and determine, does that make sense or not? So the 15th percentile, I'm getting that. The score is going to be 70.78. I'm doing that by doing second function vars, and I'm hitting 3 instead of 2. Okay? I'm hitting 3 instead of 2. I'm putting in my percentage for the area. Now you change that percentage to a number, so you have to change it to a decimal, 0.15. Okay? So my decimal is 0.15 for my area, and then below I just type in 77.6, my average or my mean, and my standard deviation. I hit enter, and I should get my score. Okay. $30,000. It's always the initial investment times the percentage raised to the year. All right. When it's depreciation, you take that percentage and you subtract it from 100. So if it depreciates 8%, you're getting 92% of it every year. And it's for 4 years. That's literally the answer. Okay? The rest comes down to knowing how to use your calculator. 0.92 raised to the 4th power is 0.72. And then I multiply that by 30,000, 21,491.79. So this is a case where we're given the final output, we want the initial input. After 5 years, my stock is worth $38,643. I want to know what it was initially worth if it was decreasing by 3% for 5 years. Decreasing or depreciating at 3% means it goes to 0.97 raised to the 5th. Once again, we deal with our exponent first. 0.97 raised to the 5th. 0.97 raised to the 5th is, and I am rounding here, 0.86. Okay? And then when I divide both sides by 0.86, I'm actually going to divide what's in my calculator, but I'm just going to write 86. So we're going to get 38643 divided by, and I'm going to get $44,999.96. I'm just going to make that $45,000. So essentially, if I have a $45,000 investment and it's losing 3% every year, okay, and I ended up with $38,643, that's what I started with. So in this problem, I invest $60,000 and it does a lot better. Okay? It grows 7% annually for 7 years. How much money do you have in 7 years? So when we have a growth, it's 1.07. It's 1 point, whatever that percentage is, for 7 years. And now, once again, I'm just doing my exponent first. 1.07. 1.07 to the 7th power. I'm going to round here. It's about 1.61. I won't round in my calculator, but I'll round just to right on the board. And then when I multiply that answer by 60,000, I get $96,346.89. And that's my answer. The deal is the second one on the other page. I end up with $32,210.20 after my investment, my original investment, so that's why the X there, the original investment is X, increased 10% for 5 years. So now I'm just going to do a 1.1 raised to the 5th, and that's, I'll actually write the entire number here. 1.61051, and now I'm going to take my 32,210.10 and divide it by 1.61051, and I'm going to get 19,999.93. We're going to call that a 20,000 investment. You can round it. Okay, that's about a $20,000 investment. And once again, I would argue there, if I give you $20,000 and 5 years back, or 5 years later, you give me 12,000 and change back, more than the 20,000 I gave you, I'd say that's a pretty good deal.